4, measure and classify angles. Let's first talk about an angle. Yes, right there on that closet. Do you see it? So when we talk about an angle, there's specific parts to the angle that you need to be able to reference. The first is what's called the vertex. So your vertex is where your two sides of your angle are going to meet. Really, it's the vertex that you're going to be measuring when you're looking for a measurement of the angle. Okay? And then the sides would be the sides of the angle. Now notice what geometric figure is the side of the angle. You just look at one side. Is it a line, line segment, a ray, a plane? It's a ray, right? It has an endpoint and then goes on and on and on forever in one direction. Okay, so an angle is made out of two specific rays. All right, so here is our definition for an angle. Please write down that it consists of two different rays with the same endpoint. All right, so now let's see. We know how to name a line. We know how to name a ray. We know how to name a plane. We know how to name a point. We know how to name a line segment, hopefully. So now let's talk about the different ways that you can name an angle. All right, so kind of up on the top half, oops, in highlighter mode, of your box there under naming, make a little angle. All right, so the easiest way to name an angle, and when this happens, you're going to be happy, sometimes they'll put a number, I'm going to put the number 1, inside the angle. If that is the case, I can name that angle, angle 1. And you put a little angle in front. Try to make the bottom half of your angle flat so that it does not look like a less than sign. Do you guys remember what a less than sign looks like? So less than is more like this. Angle kind of has a flat bottom to it. You see the difference? Okay. So that's the easiest way to name it. If it had a 2 in there, then I would call it angle 2. If it had a 3 inside, then I'd call it angle 3. Whatever the number is, you could just say angle whatever the number is. All right, well, it's not always that case. Sometimes it will have a letter at the vertex. If it has a letter at the vertex, another way I could name it would be angle A. Or it could be angle B or angle C. Okay, this one's not quite used as often, and I'll explain why here in 2 seconds. And then sometime, let's add 2 other points, B and C, onto my rays. What I want you to get in the habit of doing is the following type of naming. And that's using 3 points within that angle and making sure that your vertex is always in the middle. So I could call this whole entire angle, angle BAC. With A being the vertex and A being listed between the 2 other points. I could do it in reverse, or I could call it angle CAB. That would be okay. Again, as long as my vertex is in the middle. Okay? And the reason why I want you to get in the habit of using all 3 letters is because of what the next example looks like. All right, so everybody has these all written down? Yep. All right, so let's look at this diagram here. How many angles do you see occurring? Do you see all 3 of the angles? How about this? Do you see two of the angles? We have the top angle and the bottom angle, right? What if you took away that middle ray? Then wouldn't you have the whole angle? Right, so there would be your three angles. Okay, so we want to name the three angles in the diagram. Anthony.
Naming all three or just one?
Go for one.
WXY.
WXY. I like that. So let's do angle WXY, which is this angle right here. So it means I'm starting at W, my vertex is at X, and going at Y. So Anthony just took care of that top angle. What will be the bottom angle down here? Chance?
Y and Z.
Good. So angle Y, X, Z. Could we have gone ZXY? ZXY. Sure, we could have. X is still the vertex, so X is still in between. So we can switch the order. Okay. What about the largest one? What's that one going to be? Yeah, WXZ or ZXW, whichever order you want to make it. So angle WXZ. Now, if I look at this angle, if I were to say, don't write this, just watch. If I were to say, well, I'm going to call it angle X. Would you know what angle I'm talking about if I just said angle X? No, because didn't we just prove that there were three separate angles that have a vertex of X? We listed them. So if I just said angle X, I'm not being specific enough of which angle I'm talking about, because all three angles have a vertex of X. So that's why I want you to get in the habit of just listing all three of them. The only time you can do just X is if this whole bottom half was gone and I was only left with that top half. Then you could say angle X and that would be correct. Okay? But it's not correct in this case because I have more than one angle happening. All right? Okay, so now let's talk about how to measure angles. We use a ruler to measure line segments. We use a protractor to measure angles. So, let me get protractors out to you guys. Let's see if I have enough of the mini ones. Those usually work a little bit nicer. No, but I do not. All right. So, we use protractors to measure angles. Have you guys used protractors before? Good. So we all should be masters of the protractor. All right. Now these big ones are a little bit harder to use because sometimes the lines aren't long enough. So, if you want to measure an angle with a protractor, let's quickly talk about a protractor. You can look at the one I just gave you. Notice down here on the bottom straight part, there's like a little circle, or some of the protractors don't have circles, they just kind of have a line. That's where you want to put your vertex of an angle. So your vertex of your angle always is going to go at that dot. Now we've got two rays on an angle, right? Then we just write that an angle consists of two rays. We've got the initial angle, and we've got, I'm going to call it the terminal angle. When you think of the word terminal, what do you think of?
Like an airplane.
Like an airplane, right? So you're going into a terminal to fly away on an airplane, right? So you're moving in that terminal. So your initial ray should be the ray that stays stationary. If we think about this ray being the terminal ray, I could move that and it can turn into, bless you, any type of degree that I want it to be. So you need to decide which one you want to make your initial, which one you want to make your terminal. Your initial ray should line up with that bottom line. And then notice you've got two rows of numbers. They start from 0, they go to 180 degrees, and then it goes from 180 degrees to 0. So that means when you look at where your terminal ray is moving, you've got two options. You've got 40 degrees and you've got 140 degrees. Which one do you think would be the correct one for this angle? 40 degrees or 140? Jackson, what do you think? 40 or 140? Jackson and Connor. Jackson and Connor. 140 or 40? Which one do you think is the correct angle for this? 140?
Oh,
140. Yeah, because we're going this way. So whichever direction your initial ray is pointing to, you want to look where the 0 is, and you're going to follow that set of numbers. All right, so here I have some angles already here with a protractor. What's going to be the measure of this angle? So it's crossing right here. Yeah, 125. So we would say that the angle is 125 degrees. Remember, angles are measured in degrees, so we put a little degree sign up there. What's the second angle measuring at? Okay, now let's think. My initial ray is pointing here. 0 is on the bottom set of numbers. I'm going to follow the bottom set, which would put me at 100 degrees. Okay. All right, flip on to the next page. Now let's talk about classifying angles. You guys did this in your word search on day 1, and I told you that one of these will be on your midterm exam, being able to define an angle. So you want to make sure you can define them. What would be an acute angle? Anthony? Less than 90, but we want to make sure that it stops at 0. Because if you start going into the negatives, then we get into a whole new world. So we want to say that it's an angle that measures between 0 degrees and 90 degrees. And what would an acute angle look like? It's going to be really cute, huh? Okay. So just make an angle that is less than 90 degrees. What about a right angle? Yeah, that's going to be exactly 90 degrees. So an angle that measures exactly 90 degrees. So when we make a right angle, what we end up doing, so that we know for sure that it's a right angle, is you end up putting this little box in the corner of your right angle. The only time you can assume that something is a right angle is if it has that little box in there. If it doesn't have the box in there, then do not assume that that angle is 90 degrees. Did everybody hear that? Do not assume that something is 90 degrees unless it has a box in the angle. Okay? All right, obtuse would be what? Between what two numbers? 90 and 180. Okay, so make yourself an obtuse angle over there in the example. And then what would be a straight angle? Exactly 180 degrees, good. And that would just be a straight line. All right, so now we're going to combine the protractor together with the classifying. So if you're ever asked to classify an angle, you'll call it acute, right, obtuse, or straight. If you're ever asked to name the angle, that's when you actually physically name it, angle ABC or angle BAC or whatever it would be. All right, so here is our next example. Use the diagram to find the measure of the indicated angle, then classify the angle. Okay, so the first thing we're going to do is we're going to find the measure of angle LHJ. Now, I'm going to add a little bit to this notation. Are you ready? If you're ever asked to find the measure of an angle, there's going to be a little m in front of that angle sign. And that means I'm talking about finding the measure of angle LHJ. All right, so how do we find angle LHJ? Well, locate where L is, go down to H, end at J. How many degrees is that? 90 degrees. How would you classify it? That would be a right angle. Very good. Bless you. All right, next one. Find the measure of angle GHK. So GHK. That means we're starting at G, going to H as my vertex, going up through K. How many degrees is that? GHK. Well, first, which set of numbers are we following? Here's my initial ray, so that points in the left direction. I want to look to see where 0 is. 0 is in the top set of numbers. So I'm going to follow the top set of numbers around. So what is that, 125? Yeah. So that's 125 degrees. How would you classify that angle?
As a obtuse.
Perfect. See, look at this. Nice and easy. Okay. Let's do one more. The measure of angle KHL. It's going to be a little bit trickier. So angle KHL. Oh boy. Is my initial ray on a 0? Nope. So how are we going to figure out how many degrees that is? Me personally, I would just count units. I would start here at 90. 90 to 80 is how many units? 10. 80 to 70 gets us another 10. So now we're at 20. Going to 60 makes us get to 30. And then how many more to get to that little array over there? 5 more. So 35. Right? So that's how I would personally do it. 35 degrees. Or you could subtract 90 minus 55, because this is at 90 and this is at 55, which would get you to 35 also. Classify it as acute. Good. All right, so now let's actually use our protractors to practice making angles. All right, so we need to construct an angle that is going to be 75 degrees. How are we going to do that? Well, the first thing we need to do is we need to make an initial ray. So somewhere in that blank space, use the straight edge part of your protractor and make a line. Put an arrow on the side and make it look like it's a ray. Make a line, put an arrow, dot for your endpoint. Okay. Now, how am I going to get that terminal ray to go to 75 degrees? Well, we're going to put that hole, the center of our protractor, on top of our vertex. We're going to line up our 0 line with our initial ray. And then I'm going to follow the inside set of lines, because my arrow is pointing to the right counter. I'm going to follow that inside line to 75, so 5 past the 70 line. I'm going to make a mark. And remember, you only need 2 points to make a line. So there's 1 point. Your vertex is a second point. So then using the straight edge of your protractor, connect. Put your ray. You get it? Alright. So we should be good to go with classifying angles, using a protractor to measure an angle, and all that fun stuff. Yeah? Do we need to practice measuring angles with a protractor? I don't think we got that. All right, so now let's move on to what may be the new part of angles that you didn't learn in second grade. And that is angle addition. Now, angle addition is the same thing as segment addition. It's just now we have angles instead. So please write the following. The measure of angle RST. So the measure of angle RST, get that mouse out of there, equals the measure of angle RSP plus the measure of angle PST. It's just like segment addition. Instead of a segment, we have the angles. Segment addition, remember we said AB plus BC equals AC. So the two parts added together equal the whole. All right, so here let's make a nice big angle. For angle RST, which letter should be at the vertex? S, thank you, because that's in the middle, so I'm going to put S down here at the vertex. Let's put R somewhere up here on that ray, and I'll put T somewhere over here on this ray. All right, so there's your whole angle. Now let's get to the angle addition part. Put an angle shooting through somewhere between your big angle. Does not need to be exactly in the middle. Jackson and Connor. What's the next, what point should be on that ray? It should be ray what? Yeah, so we need a P on there. Okay, so if we look at this, angle RSP added to angle PST should get you the whole angle, right? All right, so angle addition, just like segment addition, the algebra is going to stay the same. The only thing that's changing is the diagram is now angles instead of line segments. So you already know how to do this because you did it in section 1.2. All right, so we need to find the measure of angle ABC. That's our end game. Before we can do that, we got to do a little bit of adding. So ABC is the whole entire angle. If the top half is 44 and the bottom half is 26, what's the whole thing going to be? 70, right? That's all we have to do. So the measure of angle ABC is equal to 44 plus 26, which is 70. So measure of angle ABC is equal to 70 degrees. All right, well, what if we're not given both halves? What if we're given a whole and a small part, like in the next example? Here it's telling me that angle ABC, the whole thing is 120 degrees. Angle DBC is 70 degrees. How would I then find the measure of angle ABD, which is up here? Yeah, because we would do 120 minus 70, right? So the measure of angle ABD is equal to 120 minus 70, which is 50 degrees. So measure of angle ABD is equal to 50 degrees. I'm only writing this out so you have it for your notes, for when you refer back to it, you know where a number came from. Okay. All right, let's throw some algebra into our lives. So are you ready? Okay, so given that the whole entire angle is 145 degrees, So the whole angle, angle LKN, LKN is 145 degrees. I need to find each individual angle. So angle addition tells me I can add my angles together and equal it to the whole thing. So my top angle, angle LKM, is 2x plus 10. So let's write that, 2x plus 10. Plus the other angle, which is angle MKN, 4x minus 3. And then we're going to equal that to the whole angle degree, which is 145. Now we have an equation, hopefully we all can solve. Combining like terms, I have 2x and 4x, which is going to make us have 6x. 10 minus 3 is a positive 7, equals 145. Subtract 7 from 145, gets us 6x is equal to, what is that, 138? Divide out 6. 6 goes into 13 once, or sorry, twice, because that'd be 12, remainder of 1, so 18. 6 goes into 18 3 times. So x is equal to 23. I'm not done. What am I asked to find? These two angle measures. So that means I would have to do what? Plug it in. So the measure of angle LKM is going to be equal to, well, we have to do 2 times 23 plus 10. So doubling 23 is 46 plus 10 is 56 degrees. So there's LKM's measure. Now let's go down to the bottom one. 4 times 23 minus 3. All right, let's do some mental math. 23 times 4 is 92. 92 minus 3 is 89. Yeah? So the measure of angle MKN is 89. Now check. Does 56 plus 89 make 145? Yeah, so we know we did it right. Okay, so the process is no different than segment addition. It's just instead of segments, it's in angle form. All right, now let's quickly talk about congruent angles. Remember when we talked about congruent segments, what did we do to show that we had congruent segments? What was our notation? If I had a segment here and it was congruent to this segment here, what would I do on those lines to show they're congruent? I would put a little tick mark, right? And if I had another set, instead of just one, I could do 2 tick marks, or I could do 3 tick marks if I needed a third set of congruent, right? Keep on going. Well, the same thing happens mostly for angles. Instead of tick marks, we're going to use a different notation. So, congruent angles are 2 angles that have the same measure. So 2 angles that have the same measure are our congruent angles. So over in your diagram, try to make 2 angles that look like they have the same measure. To show congruency in an angle, we put a little arc, bless you, inside the angle. And that can turn into a double arc, or it could turn into a triple arc, or a quadruple arc, however many arcs are necessary for the diagram for the congruencies. Okay? So flip on to the back. So where are congruent angles? Which angle is congruent to P? So I'm going to write angle P is congruent. Remember, that's our symbol for congruent to angle R. And which one's congruent to T? Angle T is congruent to angle S. Good. Okay. All right, let's finish this up. I know there's a lot going on in your brain, but the concepts should all be similar to what we've been talking about line segments. When we say the word bisect, what does that mean? Cuts things in half, right? So the same thing occurs for an angle bisector. So for an angle bisector, it's going to be a ray that divides an angle into two equal parts. Okay, so remember, whenever you see the word bisect, no matter if it's a segment being bisected or an angle being bisected, it's being cut into two equal parts. So if we have an angle, and we have an angle bisector, it means it's just going to be a ray going directly through the center, and it's going to split it into two congruent parts. I'm going to put the little arcs there to show congruency. Connor, please put that phone away. All right, so for the last example, in the diagram at the right, well, it's actually on the left, ray YW bisects angle XYZ. The measure, all right, here I'm giving some information, so let's fill it in. The measure of angle XYW, so that's that top angle, is 18 degrees. I'm going to put that little 18 up there. Find, they're looking for the measure of angle XYZ. So if that top half is 18, what's the bottom half going to be? 18, so the whole thing would be 36. So the measure of angle XYZ is equal to 36 degrees. If they threw algebra into the mix instead, so for example, just watch, this was x plus 2 degrees and this was 3x minus 4 degrees, what would you have to do? Would you add those angles? If it's a bisector, we wouldn't add them, we would equal them together, solve for x, and then plug it back in, right? All right.